Topic is looking at the generic privileged accounts in the Oracle E-Business Suite. And specifically, we picked out a couple accounts to talk about the APPS, SYSADMIN, and Oracle accounts at the different technology stack layers. And so what we'll do in this presentation is go through each of those types of accounts and discuss some of the controls, logging, and monitoring that you need to be doing in order to have a well-controlled environment and protect from fraud, abuse of these generic accounts, because they are very powerful accounts and they have a significant amount of privileges, and they can easily be shared in most environments, and a lot of organizations don't control these accounts well, and so they have a lot of different people using the APPS account. The APPS account is used for different interfaces and things like that, and we'll talk about some challenges and issues with these accounts, and then we'll discuss how you should be better controlling these accounts in your environment. We'll start with an overview of the different privileged accounts, and then we'll talk about them in detail and go through each account, looking at how you can control it, how you can monitor it, and what you should be doing if you're an internal auditor to actually audit the ad account. Then we'll talk about some best practices, and especially in terms of logging and monitoring Password Vault. And then we'll finish up with a Q&A. So before we get started, for those of you not familiar with Integrigy, Integrigy was founded in 2001, and we specialize in Oracle E-Business Suite security. We have two parts to our business. The first part is a set of products. The first is AppSentry, which is actually an auditing tool that is specific to Oracle E-Business Suite and can also audit databases like Oracle and SQL Server. And then we have a enterprise application firewall that's specialized for the E-Business Suite. So if you're running products like iSupply or iRecruitment, iStore on the internet, this is another layer of defense. It provides virtual patching for your internet environment, so you don't have to apply the critical patch updates as quickly. And then from a lot of what we do is our services, especially in terms of security assessments. And a lot of this presentation is based off of our security assessments that we do at a lot of different organizations every year. And we identify problems with, as example, these generic privileged accounts. And then we provide recommendations to our clients on how to protect this. And then we also do a lot of compliance work in terms of SOX, PCI, and HIPAA, and then also work with a lot of our clients to help them implement auditing, encryption, secure their DMZ environment. This is an educational webinar, so enough about Integrigy, and we'll kind of get into the topic today. So we'll start talking about these generic privileged accounts. And the first thing we'll do is actually do a definition of generic privileged account. So in an Oracle E-Business Suite environment, we have the application, database, and operating system. And for administration purposes, there's a number of accounts that are created at each of those layers of the technology stack. And the two key attributes for these accounts is, one, they're used by multiple people, so they're generic. They aren't a named account. And two, they have significant privileges. In terms of all the accounts we're going to be talking about, they can access everything in the database. They own all the data. They can do any transactions they want. So you really need to be able to control these accounts, at least know who's using them and why they're using them. So for the Oracle E-Business Suite, there's multiple highly privileged accounts in the environment. They're generic. They're accounts like apps. They're not assigned to one person. If you have multiple DBAs, you have to have multiple DBAs know the app's password. They have to be able to use the account to manage both the application and the database. And the problem is, and the risk here is there's in terms of data breaches, most data breaches are actually committed by insiders. Some are intentional. Some people are just stealing the credit card numbers and selling them off. But also a lot of the data breaches are accidental. So someone accidentally goes into the apps account just to look around. Someone is maybe having a problem, and they kind of start poking around and can cause problems that way. We've actually seen DBAs accidentally drop tables in production thinking they were in development. These are very powerful accounts, and you at least need to have an audit trail and some controls around them to make sure who's using them and what they're doing. And so let's specifically identify the accounts we're going to talk about during this session today. First, at the Oracle E-Business Suite layer, there's the SYSADMIN account. So every Oracle E-Business Suite environment includes an application account called SYSADMIN, and this is, you can think of it as the root of the application. This is the core account that Oracle delivers out of the box, and it's has the system administrator responsibility and a bunch of other responsibilities. There's a second set of accounts we'll talk about also as part of this presentation that are also generic privileged accounts, and these are the seeded application accounts. We'll mostly focus in on the sysadmin account, but there are about 30 other accounts that you need to be thinking about at the application layer. Next, at the database layer, there's three sets of accounts that we'll touch base on today. First is APPS and AppleSys. And I'm grouping the APPS and AppleSys account together because the password actually has to be the same for both accounts. When you install Oracle E-Business Suite, you actually set the password for APPS and AppleSys to the same value. And in this case, it's usually APPS upon install, and hopefully you're changing that password. And so these two accounts are intertwined. If someone has access to the APPS account, they also have access to the AppleSys account. And the AppleSys account is the owner of the core EBS tables used for things like security, configuration setups, profile options, things like that. The second set of database accounts that you need to be thinking about is Sys and System. The Sys account is the most powerful account in the Oracle database. It's basically the root account of the database. It owns all the data, can access all the data, and can basically do anything it wants. The second account is System, and the System is actually a delivered Oracle DBA account. In most environments, we'd actually recommend you just lock that account if it's not an Oracle E-Business Suite environment, but unfortunately the Oracle E-Business Suite environment actually uses the System account quite often. And so the DBAs need to know the password and actively use it. Finally, at the Oracle database level, all Oracle E-Business Suite environments actually include 250 plus other accounts. And so for each Oracle E-Business Suite module, like General Ledger, there's an account at the database level called GL. For accounts payable, it's AP. For fixed assets, it's FA. And these accounts are used to actually own the data for each model. So if you have a table for General Ledger, that General Ledger table would be actually stored under the GL schema. Oh, by the way, each schema is a database account, and those are installed and active when you install the application. And by the way, the password is the same as the username. So hopefully you've changed these usernames and passwords. And as an example, GL, the password would be GL. And we'll talk about how to secure those accounts also. Then finally, at the operating system level, there's two sets of accounts. The key one that most people have some sort of control over is root. And in this presentation, we'll be talking mostly about Unix and Linux. We'll ignore the Windows issues. If you're running a Windows environment, Oracle E-Business Suite, you'll have the administrator account, which is similar to the root, but we'll focus in on, because most of our clients are running on Windows and Linux, we'll focus in on those operating systems, and root is the key account there. Then for the Oracle E-Business Suite, you may have one or two accounts. You have the option of actually, when you install Oracle E-Business Suite, to actually install it as just under the Oracle account or Applmgr, and you can change these accounts names. And a lot of organizations that have multiple Oracle databases installed on the same server will actually change the name to be like Aura Prod, Aura Dev, things like that. So we're using the names Oracle and Applmgr very generically here. You can actually change those names, but in this presentation, we'll just use the generic names Oracle and Applmgr. And you may have one or both. A lot of environments just use one account, and that would be, in this case, Oracle. So these are the accounts we're talking about, and we'll kind of walk through and discuss the challenges with securing these accounts and how you should control them, audit them, and monitor them. One issue that a lot of people don't understand, though, about these generic privileged accounts is that there's a lot of interdependency among them. So we talk to a lot of our clients and discuss the SYSADMIN account. They say, oh, well, that's limited to our application administrators, and we have a very good segregation of duties, and we don't give our application administrators the APPS account. So at the database level, oh, they can't sign on as the APPS user. However, any of these generic privileged accounts, if you have access to one of them, the assumption is you basically have access to all the others. Because if you have access to the SYSADMIN account, which is an application account, that account has a lot of capabilities and privileges to actually execute SQL statements as the APPS account. And it's theoretically possible for the SysAdmin account to get the APPS password from the application. So if you then have the APPS password, you can actually now execute SQL as a sys user based on different packages and the way Oracle E-Business Suite is installed. If I have access to the Oracle account at the operating system level, I can automatically connect as a sys account. If I have the APPS database account, I can actually execute OS commands as Oracle. So if you have one of these accounts, the assumption should be that that person has access to all the privileged accounts in the Oracle E-Business Suite environment. And unfortunately, this is the design of the application, the way the database works. There's really no way to limit this capability. And so you do have to be aware of that. So even if you think you have some segregation of duties, it's very feasible by just using some standard forms within the application, calling standard database packages installed with the eBusiness Suite, that you can maneuver around from one account to the other. Even if you think you've got some segregation of duties, it probably doesn't really exist behind the scenes. Normally, people wouldn't be accessing these type of functions to get control of another account, but it is very doable and very feasible, and any competent DBA could easily do it within a couple minutes. So before we kind of talk about how to control some of these accounts, let's step back one moment. When you registered, we actually asked you some questions. So the first one was, how concerned are you about privileged accounts? And over 80% of the people on the call today are very concerned about these accounts. They're here because these are difficult to control accounts, and it is a control risk in most environments. Another question we asked is, how actively managed are these privileged accounts? And only 38% of the people on the call today said very actively managed. And this is, how do you secure them? How do you make sure that they aren't shared and things like that? And hopefully we'll try to answer those questions on the call today. But the vast majority of people are not actively managing all these accounts. And that's very important, that these are very powerful accounts and may be shared, may be used much more widely than you actually are thinking. So that's a little bit of a background and overview, and now we'll kind of get into the meat of the presentation and talk about each account at each layer and discuss some of the things that you can do to control the accounts, monitor them, and audit them. So we'll start first at the Oracle eBusiness Suite and discuss the sysadmin account. So every Oracle eBusiness Suite environment has an account called sysadmin. This account is delivered with a default password as sysadmin, so hopefully at least you've changed that password. And it, by default, has a system administrator responsibility, which is the key responsibility for system administration within the application, and it has 13 more responsibilities in most implementations. One thing about Oracle that, to me, is a security issue, this account must be used and must be active at all times. There are certain functions that can only be done through sysadmin. Even if you grant out the system administrator responsibility to other users, there are certain functions within the application that require sysadmin. And the sysadmin account must be always active, because if you attempt to end date it, some functions, especially related to concurrent manager, will stop working. So there's nothing you can do to basically shut off this account. You have to have it. It exists. It has access to everything. You can take away some of the responsibilities, but it still, at the end of the day, always has to have system administrator responsibility. So this is just kind of a inherent security risk and flaw within the application. This has actually been fixed supposedly in 12.2. We haven't tested it thoroughly, but we have reports that from Oracle that they've worked on this problem and have attempted to fix it in 12.2. One of the big issues is this is a generic account, and if the password is shared around, who might actually have access to it? And most organizations, they do give it out to the application administrators and the application DBAs, but we actually do a lot of auditing, and when we do our security assessments on site at clients, we actually go through and try to figure out who's using the sysadmin account. And hopefully you've got sign-on audit running, and if you look at the FND logins table, you can actually see who's signing on to sysadmin. And a lot of times you'll see people from the help desk, you'll see consultants, you'll see power users, all have access to the sysadmin account and they're actively logging into it. So how should we be controlling this account? Well, sysadmin should never be used except for those very specific functions. You should need to be narrowing it down to only a few people have access to the sysadmin account, and every other major function performed within the application should be used named accounts versus using sysadmin. And hopefully now, at least if we can control it, filter it down to just a few application DBAs who have access to sysadmin, because that's typically who would have to go in and perform the functions. One way to control it is if any access to sysadmin should require a change ticket in production. So if the application DBAs need to do a function, there really probably should be a change ticket associated with that, because that's typically a big change to the application. One thing that a lot of clients use sysadmin for is scheduling a lot of concurrent manager programs. So there's always those standard administration programs running, some of the purge routines and things like that, some of the optimization routines, some of the statistics gathering routines. They schedule those under sysadmin. In some organizations, they schedule everything under sysadmin. which there's a security risk. You should try to create custom, less privileged accounts for those type of scheduled concurrent programs. And then you can use also the proxy user functionality in release 12 and on to actually control access to those less privileged accounts. So what that means is rather than giving out the direct password and user ID to somebody, you actually give them proxy users so they can actually proxy to it. That's a standard application functionality. Therefore, they don't have to directly log into it, and now at least you have a sign-on to a named account, and then you can see the transition to the generic account. That's a very powerful feature to help control on how these accounts are used. Another thing is you should always change the sysadmin password when cloning. We see some clients that are taking the sysadmin account and it's the same password in development as it is in production. And a lot of times they'll open it up to developers in development and now they know the production password. Finally, you should be managing the sysadmin account in something like a password vault. You should be requiring the DBAs to be checking that sysadmin account password out, so at least now you have some audit trail of how that account's being used. Logging and monitoring, you should be implementing a logging framework. We'll talk more about that later in the presentation on how you should be auditing this account. Every time someone logs into the sysadmin account, potentially raising an alert to a manager, maybe the manager of the application DBA, so, oh, by the way, someone logged in, and monitoring all usage of it. Finally, if you're an internal auditor or you're doing an IT security audit of Oracle Business Suite, check that the password's being changed, that there's strong password controls around it. And then finally do an interview on who's actually controlling this account, who knows the password, who should be logging into it, and then finally pulling out the report on, okay, who's actually logged into the account how many times. Does that correlate? Does that make sense? So that's the sysadmin account. It's a little bit easier to control, at least if you can narrow the scope down. Also in the Oracle Business Suite application, there's also Oracle delivers 30+ seated accounts. And this is a list of just a few of them. Most of the accounts don't have significant privileges, but there are at least 8 that do have very powerful privileges, system administrator in a number of situations. And these are all active when you install the application. They all have a default password. So these accounts also need to be controlled. So these are there. And there's only 1 or 2 of these seated accounts that are typically used in any Oracle Business Suite environment, and those are used for things like iStore. So there's an EBS guest account, which has very limited privileges. That's used for iStore. But generally, all 30 seated accounts need to be disabled. And so the way to control these seated accounts are basically the best practices for security for Oracle Business Suite is to end date these accounts. Integrigy also recommends you actually change the password to a random string and just throw that password away. We like to both end date it and change the password because if something, for some reason, you apply a patch and it actually gets rid of the end date, now at least if you've changed the password, it's hard to log in. There's certain hacks that we do is we have the ability to actually sometimes change the application password. And one of the key things we always go after is an account like OP-SysAdmin. So if we can find a security flaw in Oracle Business Suite, we'll do things like change the password to the OP-SysAdmin account because we know it may not be end dated and we can kind of quickly get it in. People a lot of times aren't monitoring for it, and it's a very easy way to hack in. And that's kind of why we recommend both end dating and changing the password. And you never need these passwords, and you just kind of change it to a random string and throw the password away. One of the things we always like to do on logging and monitoring is these accounts should never be used. And it's a very finite list. It's well known. It's well published on the internet. So any attempt to access these accounts is really someone trying to hack into your application. So it's very easy to actually set up an alert. So I get the logins. I see failed logins. If I see any failed logins or actual logins to accounts like OP-SysAdmin, I have a very high alert that goes out in email or goes to my security team that identifies someone trying to attack these accounts. If you're auditing this and you're going through the Oracle Business Suite, you need to be checking all 30 of these accounts to make sure that they have been end dated, that the password's been changed. And one of the key issues we see a lot of times is these accounts are added dynamically by Oracle during patching. So if you do an 11-eyed R12 upgrade, you'll actually get some more of these seeded accounts. And if you go to Integrigy's website, we have a security quick reference for the Oracle Business Suite. We actually list all these accounts out. You can download that from our website and to get a finite list of them. But some of these are actually added during upgrades, and they have default passwords. So unless you're checking after your 11i to R12 upgrade, you'll actually have 3 or 4 new of these accounts, and they have default passwords, and they tend to be active. So you really need to be checking for these accounts over time that they exist. So that's kind of for the seeded generic accounts. These are accounts that people don't usually think about as being privileged, but they have system administrator type privileges for a number of them. So that's at the application level. The next big area is the database, and we'll talk about a couple at the database. Before I do that, what we do at Integrigy is we have a database account classification model. So we go through and take every single database account in a standard Oracle E-Business Suite database when we do our security assessments and actually map them out to different categories. And each of these categories results in a set of policies and procedures around the account. The ones in yellow are the ones we're going to be talking about today. So there are other accounts, there's named users, like hopefully you're creating named DBA accounts and things like that. But you should be thinking about your database accounts in this type of model to say, yes, each of these accounts has a different set of controls and risks associated with it, and I need to look at them differently. So a named account is very different than a generic application account, the way you control it. So there are a bunch of accounts at the Oracle EBS database layer, and there's a number of very privileged accounts. Almost every standard account in the Oracle database is privileged and it's generic. We'll talk about most of them here. So generically, for every Oracle database in the world, you always have a sys and system account. The sys account's the owner of the database, and you really have to use it. You can't disable it. You actually can't even lock it out if you do failed password attempts. Then there's the system account. This is the generic DBA account delivered by Oracle. In most Oracle databases, non-Oracle EBS, let's say your data warehouse, you can actually disable and lock the system account, and that's our recommendation. But unfortunately for the Oracle E-Business Suite, this account must be active because the first thing you do is when you run AD patch to apply patches or AD admins to do some administration activities, you actually have to supply the system account's password. So the application DBAs must know the password for the system account. Again, this is another area where now we're losing control because we have people logging in consistently as a generic account, and they have to know the password. The big account here in red for the application is the apps account. The major problem with Oracle E-Business Suite on trying to control the apps account is the apps account does everything. So anytime an end user logs into the application, all their SQL statements execute as apps. Anytime you have a concurrent manager program, the batch processing system running, all that runs as apps. Anytime a DBA needs to go in and do any kind of maintenance, they run things as apps. So this account is used for everything. It's got all access to data, and it also has access to encrypted sensitive data. So even if you're running things like the Oracle credit card encryption patch, the apps account still has access to it. And then also the account AppleSysPub is very tightly related to the apps account. The password has to be the same for apps as it is AppleSys. And so if someone can access the apps account, they can always also access the AppleSys account. So you always have to be aware of that relationship and try to manage that. And then finally, we have the schema owner. So again, I talked about the general ledger AP accounts. There's over 250 of these. By the way, every single one of those accounts has full DDL privileges. So it can create any objects in the database, even outside its own schema. So even though these accounts should only own the data, like general ledger data, they also have very significant privileges in the database. So before I go talk about how to control each of these accounts, I do want to highlight database passwords. So database passwords are always an issue, so you should always be very cognizant of what accounts are in the database and that the passwords are changed. And this is a little chart that we come up with when we do our security assessments. We take the anonymized data and actually put it together. So this is about a sampling of over 120 production databases, many Oracle E-Business Suite, and these are only the standard database accounts. And this shows you actually when we do our assessments how often we find a default password. So when we're looking at the DBMS and MP account, we find it in 99% of the databases, but we find 50% of the time it has a default password. Well, this account can connect to the database and it has some privileges, and actually, based on critical patch updates, I can actually take over the entire database. So just a little side note, always be careful of the default passwords in an Oracle database and spend a lot of time looking at that. So when we're talking about controlling these accounts, we start with the sys database account. So there's two ways you can actually manage accounts and passwords. And I talked about the sysadmin account. I said you should manage the password with a password vault. So you should be storing it in a password vault, and we'll talk about password vaults later. In this context, we're actually saying you should control the password with a password vault. And some password vaults have the capability to actually change the password dynamically. And actually, every time I try to get the password from the password vault will go out and change the password. And then when I'm done with the password, I'll actually go back and change it to a random string that only it knows, and I can't access the account again. That's a very tight control and very powerful. The second piece is the sys account should only be used for very specific functions. Your DBA should always have named DBA accounts, and they should be going into the named DBA account first, and only when they have to do something that requires a sys account, they should be using that, because now I'm getting away from using a generic account. Unfortunately, that generic account has to be used. Whenever I use a sys account, I should be able to have a ticket required for that. So if I have to maybe create a table space, there should always be a ticket for that creation of a table space. Therefore, now I have to go in as a sys account to create that table space. When you're doing cloning, you should always be changing all the key database accounts on that clone. When I'm looking at logging and monitoring, I should be logging all activity for the sys account. I should be turning on at the database level, there's actually an initialization parameter, audit sys operations. So no matter how I go into the sys account, if I go in through the operating system, I'm still doing a full audit trail. You should be sampling and reconciling some of the change tickets to the actual usage of the account. Finally, if you're actually doing an audit, during the audit, ask how the sys account's being controlled. Who owns the password? How is the password being controlled? Has the account password been changed? We actually did a recent audit, and we found the sys password had not been changed in 15 years. It was kind of amazing that the database had been upgraded so many times. And like, oh, we don't really know what's going to happen if we change the sys password. But 15 years is probably a little too long to have a single password. I wonder who actually in the organization knows that password, because they didn't have auditing turned on, so we actually had no idea who was actually using the sys password, who had the password. So that's the sys account. Then the second account is the system account. And the system account is a full DBA account. There's really no reason except for the few EBS functions that the system account ever should be used. When you run AD-patch and AD-admin, you have to have the password. In this case, again, we think the password should be controlled with a password vault. And so I have to actually go, before I run AD-patch, I have to go connect to the password vault, request the password. It'll actually change the password for me, and then I'll actually use that password. And then when I'm done with it, the password vault will go back and change it again. Again, I should be logging and monitoring this account. I should be checking the last time the password's changed. So the system account, the recommendations are very similar on how you should control it. The next key account is the APPS account. This is the very difficult one to manage, because really APPS is used for many different functions. But again, if you're trying to manage it, you should be putting the password in a password vault. If the DBAs need it, they should be requesting it. In this case, we're saying the password vault should manage the account, not control it. When I ask for the password, I cannot change the password every time I ask for a new one from the password vault, because the password is not only stored in the database to allow me to log into the database, it's also stored in the application to allow the application to log in. So I can never truly change this password just on demand. I have to actually go through a pretty complicated procedure to actually change it. Again, my DBA should not be using APPS for every single little administration function they do. They should be always trying to be using the named DBA accounts before they use the APPS account. There is one big problem that we see. We actually do a lot of audits, and we actually had a frantic phone call a couple weeks ago from a customer that said the APPS account got locked, the application is down. You do have to be very careful about controlling the APPS password and not have things like account lockout. The Oracle 11G database comes by default with an account lockout, so failed login attempts. If it's more than 10, it'll actually lock the account. That's by default. So if you go into your APPS account, do 10 failed logins, it'll actually lock the APPS account. If the APPS account is locked, the application comes to a halt. So you do have to be very careful on the password control. So you should have a separate password control for the APPS account that does not have a lockout, but also has very strong password controls. We recommend the standard password length for the APPS account be 9 or 10 characters. So make it much more difficult to brute force the account to attack it. Logging and monitoring for the apps account is very, very difficult because the problem is everyone's using that account. So you really have to go through a very rigorous process to try to figure out how you want to monitor it and log it, and that depends on the tools that you're selecting and what kind of controls you're looking for. We recommend at least doing all logins, key security events, so if the apps account is used to create users and things like that. And we'll talk about more about exactly how to monitor and log some of these accounts a little bit later in the presentation. Another thing you need to be looking for the apps account, since you can't have a lockout on it, you should always be looking at failed logins very closely. Then if you're doing a standard audit or assessment of Oracle Business Suite, you should be checking that the apps account is periodically rotated. See who's logging into it. Try to figure out who's got access to it. Really, the apps account should be locked down to the apps DBAs. But we see a lot of times that the apps account is used for interfaces and things like that. It should be really only used for the application purposes, not for many, many other activities. And then finally at the database level, we've got the EBS schema accounts. Again, there's 250 of these accounts. There's one for each module, like general ledger, accounts payable, fixed assets. Well, our recommendation is you actually change the passwords for these and throw away the password. You can use the FNDC pass utility, and you can actually change them all at once to the same password. And we don't see a lot of risk in using the same password for every single account. You can do a nice SQL query and automatically generate some of the FNDC pass scripts and things like that. But you don't ever need the password to interactively log in. The application during its normal maintenance cycles, if it needs to access each account, will have to log in. There are a few times when you might have to load a message file into a specific schema. You actually do need that schema account then. But if that rare situation happens, you actually just go change the database password for that one account, use it, then again, when you're done with that activity, you change it back. In R12, a major feature in terms of security is that you can actually lock these schema accounts now. So there is a new command in R12, APPS WD, and if you use the option -L, which is lock these schema accounts, you can actually lock all these accounts. You have to unlock them when you do patching, but this is very powerful because now even if I do somehow get default passwords and things like that, now it's locked. When you're logging and monitoring, you should be doing the standard logging and monitoring, but again, another very specific audit you can put on is these accounts should never be logged into. I should never see a login to GL. And if someone's attempting to log in or actually uses that account, that's a security incident. I should be really looking at why someone did that. So I should have a very specific alert on any logins to these schema accounts, such as GL. Some general IT controls around database accounts. I should be having strong password profiles. I should be creating database password profiles for both service accounts and named accounts. So I probably have 2 or 3 at least of custom organizational specific database password profiles. So this tells me how long an account should be locked if there's failed login attempts, how often I have to be changing the passwords. And you do have to be very careful when you design those that you're not locking out certain service accounts. So if I lock the apps account based on failed login attempts, I can lock down the application. We recommend no one ever has, Oracle gets delivered with a default profile. No one should ever have the default profile. And I should have a routine check during my periodic security checks that if anyone's assigned to the default profile, that should be against policy. I should be looking at that and say, okay, why is that happening? And then finally, I should have a password verify function that meets my password policy. And so for any named users, I should be using that. And potentially, I should also have another password verify function for my service accounts and maybe require a little bit stronger password for those accounts, like the apps accounts. Another thing I should always be looking for is default passwords. When we do our security assessments, we're somewhere around 99% of the time finding at least one default password in every database we assess. So you should always be checking for default passwords. Oracle does have the DBA user with def password view that will actually look for standard passwords for standard accounts. We recommend use a tool like ours, AppSentry, will actually go through and try to break each account, try millions of combinations of passwords, versus the DBA user with default password only checks 700 accounts. Other tools check every single account with hundreds of passwords. So it's a very different level of checking. It's much more in-depth. So that was at the database. So we've talked about the application of the database, and now the final layer of the technology stack is the operating system. So at the operating system, you really have two accounts, Oracle and Applmgr. And again, these should be controlled with a password vault. I really should never have a direct login to either of these accounts. And the only exception there is on a rack environment. The rack environment does talk across SSH, and there's certain activities that happen there. But I really should never be seeing a lot of direct logins to the Oracle account on like an application server. What you should be requiring is your DBAs have named accounts. They should be using their named accounts to go into the OS, and then if they need to use Oracle or Applmgr, they're actually suing, sudo, or using a tool like PowerBroker to actually access the named account. In this way, we're actually enforcing a chain of trust. So we know the only way you can actually access these servers is you're going into a named account and then you're transitioning. So it's not perfect control. At least I can have some control to say that someone's not sharing the generic user account. They're just accessing it, things like that. You should be implementing logging and monitoring. If you do have the policy that only named accounts access the server, I should be having an alert looking at direct logons to the Oracle account, especially from outside IP addresses. So the key is sometimes you'll see the Oracle account actually log into itself on the same server. That's acceptable, but if I see an IP address from somewhere else in the organization logging into the server using the Oracle account, that should be flagged as a policy violation. And this is kind of the key way to control access to the Oracle account. Because remember, if I sign on to Oracle, I can just SQL plus / as sysdba, and now I'm into the database. I have access to all data. So it's very important to control the access to the operating system accounts. Some of the other key controls we need to have is the DBA should never have root access. So you should at least have a segregation of duties, and most organizations do this pretty well, but some don't, between the operating system and the database. So there are certain cases where the DBAs need to run things as root, and Oracle does a fairly good job of that. So when you install the Oracle database, they actually create a script called root.sh. And in this case, that doesn't happen very often, but then you have to call the Unix administrator, and they can go in and run that root.sh file. And again, the DBAs should always have named OS accounts. And it is possible we're seeing more organizations move away from a Unix or Linux-centric security to actually implementing that and integrating that with LDAP or Active Directory. So now when I'm logging into my Linux or Unix server, I'm actually authenticating against an external source. That's one source of truth. So if I disable or terminate one of my DBAs in Active Directory, their access from the operating system is removed at the same time. One of the big challenges we see for most organizations is termination of DBAs, reassignment of DBAs, and we look back over time and you might have 30 DBAs with access to a database server, and even though there's only 5 still left with the organization. That's a fairly significant control violation that's very difficult to manage if you're managing operating system accounts locally. Another thing we see quite often is SSH trust levels, RLogin, things like that, that you can actually set up trust between servers, which makes it really easy for the DBAs. I would love to just go in from one server, I log in as Oracle, now I can just do a quick SSH to another server without even supplying a password. That's a very significant security risk, especially with highly privileged accounts like Oracle, because once I compromise one server, I can compromise every server in the organization. So you should be avoiding things like that that allow you to jump from one server to another without providing any sort of password or passphrase. So that's at the final layer at the operating system. So that's kind of walking through each of the different layers, this very specific accounts. And now I'll turn it over to Mike, and Mike will actually walk through some other best practices talking about password vaults, logging, auditing, and monitoring.
Thank you, Steve. What I would like to do with you now is walk through some ideas, recommendations, things that we have seen work well in our assessments. I think I'm going to more highlight a few items here because I do want to get to the auditing, and I know we have some good questions that have come in. So first recommendation that we've seen work really well is to use a Bastion host. Many times this is implemented as a virtual desktop, and through network restrictions or setting up database ACLs to be able to restrict direct access to either the database or the operating system or both through this. So the idea would be is that there's strong two-factor authentication to get to this virtual desktop or Bastion host, and then you can set up keyloggers to further record activity that is transpiring through this onto the respective servers. If you are also considering Database Vault, Database Vault probably deserves a longer conversation than what we do have time for here today. But a short description of Database Vault is that think of it as a rules engine that you can set and define rules with regard to network access to servers, let's say by time of day and or content or users. That said, it does have some, though it has a management pack for the eBusiness Suite, there are restrictions with regard to, we'll say practical restrictions with regard to if you have the apps account and the apps password, what you can see. Again, if you have questions with regard to the Database Vault, I would say please contact us and we can take a longer discussion. So the concept of controlling or managing privileged accounts certainly starts with some comments. We wouldn't be complete here with this presentation without calling out some of the basics here, as far as don't use weak or default passwords, use different passwords for production, don't hardcode passwords, and practicing least privilege and need to know. But moving on, something that we commonly do as part of our audits is to go through an inventory of the accounts, ask questions, and if you are an auditor here on the phone, or here today, this is something that is probably one of the more important takeaways here, to really ask those questions, take names, and assign owners to these accounts. Next, think about the risk levels of each one of these accounts. Certainly the ones that Steve has gone through with you here are highly privileged. And when we look at password policies during our assessments and try to align our findings to the policies that the customer has put together, often we're talking about with them the need to expand and adapt controls and thinking with regard to these privileged accounts, as far as rotating these passwords on what frequency, when they do expire, the length and complexity. Steve was talking about apps passwords upwards of 10. Sometimes we've seen closer to 20 characters. Using half passwords where the half the password is given to one person and the other half of the password to a second person. But the idea here is that one size really doesn't fit all. When you're writing your password controls and you're communicating those to external, internal audit, you want to make sure that whatever sampling is done lines up to reality, and that when you do sit down and have a conversation, let's say with an external auditor about how you're managing and controlling the privileged accounts, that you have sufficient countermeasures in place. So we've mentioned a few times here in the presentation today about the use of a password vault. So password vaults are purpose-built solutions for enterprise password management. They offer very sophisticated rules and, more importantly, reports that can be used to help meet compliance requirements. Tools that we have seen are CyberArk and Dell's Total Privilege Access Manager. And we've really seen these work well as far as increasing the governance of privileged accounts. Our recommendation is to consider using a password account for all generic accounts, and to think about implementing that in a phased manner, to first get the passwords inventoried, then get them into the password vault, and then start considering rolling out functionality that Steve was alluding to earlier as far as dynamically changing of those passwords, either on a rotation basis or on an as-used basis. Further, what we've seen work well with password vaults are adding fields, for example, for ticket numbers, and then being able to log all of the password polls as well as password definitions out to tools such as Splunk or ArcSight via syslog. And this gets a very powerful reconciliation tool to be able to triangulate the session logon to the password poll. And other uses of password vaults here are really to help automate the expiry rotation process and even for rescue IDs. Access management is really a lot of what we've been talking about here today. Certainly the idea for privileged accounts and how to manage privileged accounts within the context of SOX or PCI, HIPAA. The bottom line here, and we're going to go into this a little bit more in our audit framework here, and I think I have a few minutes left that I will be able to spend some time on that. But the overall database security program is really built on a firm, sound foundation of an access management policy, and this is a lot of what we help people think through in our assessments and engagements. So logging and auditing really is the key here. Everything that we've talked about here today comes down to a level of trust, and that you need to trust hopefully a team of people that you have appropriate trust in them and in their job function, but the verification is constant. So there is ways of approaching this, and our idea here is that we want to think about the idea of constant auditing. There's a lot of audit functionality, log and audit functionality within both the database and the e-business suite. Most people we don't see taking advantage of that. We've put together a framework to help get you started. Quick overview of this framework here is that we have drivers coming down as far as requirements, be it HIPAA, be it SOX, be it PCI, and that there is a starting point with regard to a foundation layer of events that we need to trap to meet those compliance requirements, and then we've mapped that to the specific tools such as syslog, such as within the e-business suite, the audit trails and page level access tracking. The idea then is once we've drawn the X on the treasure map and we've showed you where to go dig to get that data, how to pull it out and then put it into a centralized logging tool such as a Splunk or an ArcSight to protect that log data and then also start creating intelligence and the attestation needed for compliance. We've broken that down into 14 key events as far as the framework here. Again, I'm going through pretty quickly here, but I do want to touch that we have mapped each one of the foundation events within the database or in the e-business suite and have, whether that's a logon or unsuccessful logon or the creation of an account, we've codified that and then brought that down into specific configurations to trap it and then locations in the respective technology to extract those logs. Here's the mapping, or at least a summary here of PCI to SOX, HIPAA 27001, FISMA to each one of these 14 events. The idea here is that PCI is really driving this. This PCI has the most specific requirements, and if you're an auditor in the audience here today, you can certainly appreciate some of the conversations that you can have with external, with potentially internal auditors with regard to Oracle in the Business Suite and how you are aligning your controls up to these respective standards. But we've actually gone through and laid out a roadmap of how to get there with 3 levels. First, laying out basic auditing and logging, getting that turned on. Second, being able to take that a step further, consolidate that, hopefully via tools such as syslog, and pulling that into centralized tools such as a Splunk or an ArcSight. And then once you have that, thinking about a level 3 where you're starting to track and the more functional level activity. Not trying to get into, we'll say, the GRC space, but really just the basic navigation of users through the suite and changes that they might be then making, as well as in the database, who's changing what, when, who's been where, when, and what did they do. Kind of pull it all together here is this slide here that we have in blue, the level 1, orange, level 2, green, level 3, and really what we're trying to do is to build up a level of maturity, which you see there on the right, where you're starting with some basic events and alerting on up into moving towards the idea of anomaly, correlation and anomaly detection. I've moved through this pretty quick, but we did do a webinar on this topic in February, and the white paper have put up here. You can download both from our website, and that will really give you a good firm foundation of how to think about logging and auditing with regard to not only the eBusiness Suite, but also really for the management and control of privileged accounts and what you need to do to govern them. So I know we have some questions coming in, so I think what I will do now is turn it over to Phil and take it away, Phil.
Thank you, Mike. Now we do have quite a bit of questions here. The first one, what are the best practices for Sarbanes-Oxley to control privileged accounts?
Steve, I can start, but really a lot of what we've talked about here today is really that, just as far as control and audit. Certainly I would think for PCI is being able to set forth recommendations for how you're writing those into your policy, and then potentially how you are managing them through a password vault, as well as what auditing you have enabled.
Okay. Next question. How do you differentiate a human logging directly into the database as APPS versus an end-user logging to the eBusiness Suite user interface, which also results in an APPS connection?
This is always one of the most challenging things when you're doing auditing, because the APPS account is used for everything within the application. And so if you are capturing the audit trail, you need to be very cautious, and we do a very detailed design around this about which application servers are they coming from and which programs on those application servers, and then you can potentially discount that traffic. You can look at the concurrent manager servers and their IP addresses, and then you kind of whittle your way down. And we look at it as a bucket concept. What you're trying to do is take a lot of log data, and probably 99% of the log data you're going to throw away because it's just the application doing its thing internally. And you try to put each type of traffic in a bucket, and what you're trying to do is get down to just those key events that are occurring by a human person. So maybe an applications DBA logging in as the APPS account. And so you sit there by IP address, program, terminal, and a couple other characteristics, and you say, okay, that's most likely the application. The problem with that is that those values can actually be spoofed. So I know the user and the IP address is really the only constant. So if you start to try to filter audit traffic by program, the program name can be actually spoofed by an attacker. So you have to be very careful about when you're trying to filter the audit logs to know what's coming in, where it's coming from, and which values are reliable. Another way to do it, and based on our audit framework, we focus in on key security events. So you can try to say, okay, everything the applications DBA did, well, a lot of stuff they're doing is not that relevant. But if you start looking at, okay, who's creating users, who's changing privileges, who's creating objects, you get a lot better feel about what's actually happening in the database. So even if the application server is compromised or they do it from the application server, at least you can start capturing that. So it is a very careful design on how to do it. And if you focus a little bit more on events like create user, you tend to be a little bit more successful.
Thank you, Steve. Next question. How should you monitor and audit privileged eBusiness Suite accounts?
Well, I think our log and audit methodology as laid out in the white paper referenced earlier there would probably be the best way to answer that question. But really, as Steve was saying there, the idea that you can't just audit anything and everything. You really need to think about levels of risk and key events that warrant closer scrutiny, be it in real-time alert or what to look for as far as trending on a periodic basis.
All right. Next one. How can you find out in advance who will be affected from password change?
This is always a challenge to know where that password is being used, and that's why it's very important to actually have some sort of logging enabled in auditing to see who's connecting to the database from where. We often see the apps account. Well, the apps account should be used in the application. It should be set up on the application servers, and the DBA should be using it. However, I can't tell you how many times we see it used for interfaces and other things. So when you're hopefully changing the app's password on a periodic basis, you have to be changing that password in multiple systems. So unless you have auditing turned on and have session level auditing to capture every single connection and know where people are connecting to it, you have no idea, and there's no easy way to do that. Otherwise, than just capturing the audit trail and knowing. Oracle doesn't do a very good job out of the box with who's connecting, last time you changed a password. Those values aren't stored anywhere, and the only way to capture those values is actually have a detailed audit trail running using either database auditing or some other database tool.
Steve, I would also argue that that's another good reason or a good use case for a password vault as far as what I've seen work well. When the questions ask who has access to this password, or if I were to change it, being able to go in, run a report out of the password vault for who has pulled the password in the last, let's say, 100 days and or who has access to it today if they wanted to pull it.
Okay, next question. Are there activity monitoring solutions that record what a user is doing while using shared accounts?
What I have seen in that case where there is the need either for potentially PCI is to reconstruct keystrokes and potentially hold those keystrokes in a protected repository, let's say up for 12 months rolling for any forensic reporting needs that could come up, is to use a keylogger. I've seen that implemented through tools if you're coming in, let's say on a Bastion host. That's commonly where I've seen it. I've also seen tools such as CyberArk and Dell's Total Privileged Access Manager that has the ability to allow you to pull that password, potentially log on for you or interactively, and then do a record of all activity, mouse and keystroke.
And when looking at password vaults, the key feature that we want is the ability of the password vault to interact with the Oracle database. So when, as an example, control the SYS account, if your password vault can actually go in and change dynamically the SYS password, that becomes very powerful. So if the DBA needs a SYS password, they go in and request it. The password vault goes and changes it to a certain value, gives the DBA that value. The DBA goes in and uses it for a little bit, maybe an hour or so. Then they actually go back into password vault and say they're done with it. So they basically check the password back in, and then the password vault can actually go out and change that password to a random string so the DBA can't access it unless they go back to the password vault to get it. So that becomes a very tight control to say, okay, I know exactly who had access to it because they had to request it out, and when it wasn't being used, the password vault basically had the account. You can't lock the account, but basically by controlling the password that tightly with some of the key password vault solutions out there, you've got a very good control over now a generic account. You know who's basically logging into it because they have to get the password from the password vault. So when you're looking at tools like CyberArk, PowerBroker also has, from Beyond Trust has that capability, and the Dell tool does too. Those are the key features we're looking at when we're looking at password vault.
Next question. How can we control SSH access in an Oracle RAC environment?
There is not a great solution for that because when you're in the rack environment, the two servers must talk and they communicate via SSH. What we like to do is actually put some restrictions around those accounts and the SSH controls there that they can only access it from certain servers. So based on the SSH configuration, you can actually put some controls around there. Hopefully you're putting controls around the data center so no one from the outside of the data center can go in, and that's another example why using a Bastion host is very powerful, that I can't directly from my desktop get to the database server via SSH. I have to go through something else. Those are the type of controls that you have to put in place to eliminate that risk. There's no simple, easy answer. I wish Oracle RAC didn't do that, but that's the way Oracle RAC works, and you don't have much of a choice.
Steve, just to touch on briefly, going back to the SSH keyless logon, what I have seen in the past is sometimes the entire DBA team might have SSH keys on their laptops for ease of use. The argument being that, well, they're not depending upon passwords, but then there's the risk if the laptop was then stolen. So more so than just server to server, really want to, in your audits, find out what accounts have keys created for them, and then track down who is using them.
Next question. Is logging activity performed using apps originating from a human being enough?
This gets into a question and back to your control. So what are you attempting to accomplish? What is the risk? What are the compliance requirements? At the end of the day, in a lot of organizations, and I think it does make sense for most organizations, the application controls hopefully should be sufficient. So any activity coming from the application itself, hopefully I can rely on those application controls. I'm logging into the application. I'm taking responsibility. So what I do with the apps account is very limited to the application. The concurrent manager programs, hopefully, again, I have controls around who can submit what programs. And so really the key risk around the apps account then for direct access is some human, like an applications DBA, accessing the apps account to do something. It's a generic account. If I don't have the proper controls, they can actually come in as Oracle to your application server, SQL Plus to the apps account, so it's generic account to generic account. I have no idea who used that apps account then. And that's why kind of having that logging, the key controls around that account. And if your application controls are good and you can rely on your application controls, really the key risk there then becomes the apps account used by application DBAs. It's a generic account. The password can be shared. So that's why I have to put specific controls around access to it.
The next question, please define proxy user. Would this be a special name, the user account created specifically for its targeted tests?
So there's basically a capability with Release 12 of Oracle E-Business Suite at the application level. There's now called a proxy user. And the way Oracle designed this was for the CEO's assistant to basically be able to go in and access the CEO's account. So the CEO is not out there every day going into Oracle E-Business Suite approving purchase orders and things. So what you do is you basically grant out a proxy user, so the assistant has access to Oracle E-Business Suite, but she can proxy into and assume the rights of the CEO's account. Every internal auditor on the call is probably falling over like that is an awful idea, and we completely agree with that. It should not be used for that type of functionality. But there's a huge issue in Oracle E-Business Suite and challenge that you need to schedule concurrent manager programs to run. Well, if you schedule those programs under a standard user, well, if that user leaves or something happens to him, well, it's under his account. So most organizations go in and basically create those under a generic account. Again, now you've got a generic semi-privileged account if you consider running GL batches privileged, and most organizations would. Well, how do you control that then? So because people are just logging into this generic account. You can actually use proxy user for that because now at least you're using it to mitigate another risk. And so if you use the proxy user within the application, you schedule your programs under a generic account, but you change the password to a random string so no one can directly log in, and so the only way to access that account is then you set it up as proxy for maybe the 5 people that you want to be able to manage that, and they have to sign into their named account, and then they proxy over into the generic scheduled concurrent manager program account. And that's the capability. And that was released as part of Release 12. It's not available in 11i, but it's a very powerful feature to do that. We strongly don't recommend you use it for the assistant to the CEO model where the assistant can become the CEO.
And Steve, I would like to add that that's part of our standard assessment, what we look for, and that if anybody on the call is interested or concerned with detecting proxy users, to contact us, and I can probably share with them a simple SQL statement that would identify who is a proxy user.
Next two, I believe you guys covered during the presentation, but I'll read them off anyway. Sure that we do get it covered. Should the application schema accounts, GL, AP, etc., be locked?
Yeah, so we covered that. So in Release 12, there's a new capability to lock the schema account. So it's the AF pass WD -L, and you can lock those. The only issue with doing that is you have to unlock them when you do patches. But it's a pretty quick command to run on both sides. So.
And the next one, you refer to Password Vault. Do you have any examples of products that can be used for this?
We have mentioned throughout the call a couple. I would certainly look at PowerBroker. I would also look at CyberArk and Total Privilege Access Manager from Dell.
All right, I believe that's the end of the questions, which are quite a few. Thank you, everybody. And that's going to conclude our session for the day. We appreciate everybody taking time in the middle of their day to hear Steve and Mike. And again, be sure to stay tuned for our next webinar, e-learning webinar, which is June the 15th, I believe. Now make that the 18th, which will be OBIEE and the 10 top risk connected with that. So again, thank you for everybody for attending, and have a great rest of the week.